Good morning and welcome. Thank you for making the journey, some from very far, to join us this week. It's good to see so many familiar faces as we kick things off today. First off, we're in Taipei. I love Taipei. I've been here many, many times, and I think we can all agree that this is truly the heart of the PC industry. And over the last 30 years, together, we created the PC category. We scaled the desktop computer, then we transitioned to mobile, and now, together, we get a transition to the AI PC. I can think of no better partners to do it with. This is our third Intel Technology Tour, and I know many of you have been with us on this unique technology journey since the beginning. We did our first one back in Israel in 2022, and we were in Malaysia last year. And of course, we're here in Taipei to do it again. Only Intel has the breadth and scale across design and manufacturing to make something as unique as ITT happen. We are leading in graphics, performance, and in AI. We're delivering this leadership at scale across the industry, and I'm going to take the next few minutes to tell you why. So let's just dive right in. We all know that AI is creating global change and providing us with powerful tools that are having a profound impact on the way we work, the way we live, and the way we have fun. This is a massive inflection point for the industry. This is driving a $1 trillion semiconductor TAM by 2030. Chips are cool again. We recognize AI is still in the very, very early stages. That's why Intel is focused on bringing AI everywhere, from the client to the edge to the data center, to help consumers and enterprises truly unlock the value of AI. For data center, we're helping organizations incorporate AI through open ecosystems, efficient scaling of AI training and inference, and modernizing existing infrastructure. And you're going to hear more about our data center in our classes and sessions tomorrow. From a client standpoint, we introduced the AI PC era by launching Intel Core Ultra in December of 2023. That doesn't feel like that long ago, but a lot has happened. Core Ultra brought together the CPU, the GPU, and the neural processing unit, also called the NPU, to deliver a radically new AI PC experience to people. In fact, many of the cool and exciting usages, like text-to-image creation, personal AI assistants, are available right now on Intel Core Ultra systems that are available in the market. And the experiences are only going to get better. And since the launch of Intel Core Ultra, we have shipped more than 8 million units to date. You might hear a different number, a larger number from Pat next week, because they just keep flowing out of the factory. And we're confident that we will ship more than what some of our competitors will ship in an entire year, already at this point in 2024. We've worked with ecosystem partners to deliver 230 designs to market and brought AI PCs to retailers around the globe. Our vision remains steadfast. We will deliver leading technology innovations to help people focus, create, connect, and learn. And we deliver those leading technology innovations through Intel processor families. So today, I am excited to officially introduce to you Lunar Lake. Lunar Lake is our next step in the journey to lead the AI PC experience. So let me just show you this beautiful chip. Yeah. It's small but mighty and certainly packs a punch. So Lunar Lake will bring you breakthrough x86 efficiency with our second generation low power island and up to 40% lower SoC power. In addition, you're going to get exceptional core performance with our new Lion Cove P-Core and our Skymont E-Core, delivering incredible power-efficient performance. In addition, Lunar Lake features another massive leap in graphics with 1.5 times faster graphics compared to just last year's generation. Based on our conversation with hundreds of developers around the globe, we're expecting that over 40% of developers will choose to run their workloads on the GPU by 2025. And we continue to invest in graphics because we know we need to provide choice and flexibility for developers by delivering a modern CPU that contains amazing compute, amazing graphics, and amazing NPU. Now, we talk about unmatched AI compute. This platform has up to 120 platform tops, up to 48 NPU tops, and we have unmatched software scale. In fact, Lunar Lake delivers a faster core performance than ARM. Lunar Lake is also going to change the way you have all thought about x86. Particularly, we are finally going to bust that myth that it can't be as efficient. Of course, we're all in on AI PC. Before that, they have to be an amazing PC first, a world-class compute and a world-class GPU. And Lunar Lake is going to deliver on all of those promises. It is the perfect example of how we're firing on all cylinders to deliver both engineering excellence and bringing leading technologies to the marketplace. We're focused on 3 key aspects when it comes to our client engineering excellence: platform first, scalable software, and silicon leadership. So let's talk about platform first. We have more than 20 partners working with us to deliver more than 80 unique designs. This is the largest fleet of AI PC design wins in the marketplace. And they will all be available ahead of holiday buying cycle this year. Many of those partners are in the audience with us here today, including local partners like Acer, ASUS, Dell, Compal, and Wistron. To our amazing partners, thank you for being here with us. Thank you for the decade-long journey, and I can't wait to see us create AI PC together. Thank you for joining us. And in addition to beautiful and sleek designs, we're working closely with PC ecosystem partners to make sure that we deliver all of these technologies with sustainability in mind. From the type of materials, the manufacturing process, our supply chain, to improve battery life performance increases across the CPU, the NPU, and the GPU. We're thinking about the system as a whole. And I'm so proud of the work we're doing with our ecosystem partners to bring incredible, sustainable PC experiences to market. And that includes our long-standing partnership with Microsoft. When Intel and Microsoft align on an opportunity, I think it's safe to say we can deliver scale. So let's take a minute to hear from my partner, Pavan, at Microsoft. Let's roll the video.
This is such an exciting time for the computing industry. We're incredibly grateful for the partnership between Microsoft and Intel. Together, we've collaborated to raise the bar on performance, efficiency, and innovation for our shared customers. It's been fantastic to see Meteor Lake's success since its release, driving and scaling the AI PC category. We're also incredibly excited about Lunar Lake powering upcoming Copilot+ PCs. Copilot+ PCs represent a new class of PCs for the era of AI. AI is woven into every layer from the operating system to the silicon. We've re-engineered Windows 11 to deliver unique AI experiences like Recall to take full advantage of the groundbreaking NPUs with the 40+ tops. We're also excited for the new apps and experiences that will be built on top of the Windows Copilot runtime. Microsoft is all in on AI, and we're energized that Intel is on this journey with us.
Awesome. Thanks, Pavan. I think we can all agree that Lunar Lake will bring unmatched global scale to Copilot PCs later this year. Now, another component of our engineering excellence is our software scale and enablement. And this is really, truly unmatched in the industry. No other silicon provider can come close to the breadth, scale, and support we're providing both the ISV and IHV communities. Software support and compatibility has often been overlooked, with people just assuming that things will work. But in today's PC environment, the importance of software enablement and a rich developer infrastructure is coming out of the shadows and into the spotlight. We're not going to just cherry pick a handful of apps that we know that are compatible. Everything will just work. And we're driving that industry transition with the AI PC, and we're working with a vast set of ecosystem partners to co-develop new AI PC features as part of our AI PC acceleration program. And to date, we've enabled more than 150 AI features and experiences through this program, with more than 350 planned by the end of 2025. We are already starting to see real, meaningful scenarios where AI PCs is helping people for good. One example is the work we're doing with the state of Ohio and Khan Academy. And I invited the Lieutenant Governor of Ohio, John Husted, to talk a little bit more about how Intel-powered PCs are helping students learn and engage in ways that are most beneficial to them. So let's roll the video.
In Ohio, Intel and Khan Academy have partnered to bring Khanmigo, the AI-powered teaching assistant and tutor, to dozens of schools across our state. Intel's new Core Ultra AI PCs help supplement Khanmigo by enhancing accessibility, ensuring privacy and data security, and improving system performance and, of course, efficiency.
So this is just one of the ways that we're delivering AI for good. Yes, AI is a massive market opportunity, but we have a responsibility to the next generation to ensure that we're working with partners like Khan Academy to extend AI everywhere for people with learning differences so that everyone has the same opportunity. And we're going to be bringing this to market in the United States, as well as Brazil and India, just to start, and it will expand from there. And in addition to ISV partners I just talked about, we have the largest library of AI models running on Intel Core Ultra. We have over 500 models that are optimized for Core Ultra, available across popular industry platforms that you know, like Intel OpenVINO, Hugging Face, Onyx, and PyTorch. We all know that models are the backbone of the AI-enhanced software feature. Things like object removal, super resolution, or text summarization, and all of these models are just one of the many critical layers of the software stack that we're working to enable and bring to the PC. So we have a cutting edge and mature infrastructure for the AI PC, and it's incredibly important as we develop our products and our technologies. And we're committed to not only building this for the AI PC industry, but we also know we have to deliver a robust tool chain for AI developers, but also a rock-solid foundation for AI software users. And that support extends even further with our AI PC developer program. Intel has a long history of enabling the ecosystem, and we're putting developer kits in the hands of ISVs to accelerate the delivery of AI experiences for all of our customers. And we're going to continue to build on that program. So today, I'm excited to introduce to you for the first time the Lunar Lake AI PC Developer Kit right out of the Intel labs. Thanks, Chris. Yes, check this out. This thin and light compact form factor gives you access to up to 120 TOPS performance across both the CPU, GPU, and the NPU. And with this kit, thousands of developers can ensure their software and their applications run smoothly on the latest Intel IP, as well as enhancing compatibility and the overall end user experiences. So that developer kit is pretty cool, but it has a trick up its sleeve. It's upgradable, and it will not only work with Lunar Lake, but it will also be forward compatible for our next generation processors like Panther Lake. So we're on track to put this in the hands of developers worldwide at Intel Innovation in September. This is going to allow the thousands of the next wave of developers to truly unleash their creativity. And you can get a sneak peek of the developer kit just next door at the showcase over the next 2 days. We're looking forward to what you think, but more importantly, I'm looking forward to what you can create. Last but not least, the third component of engineering is silicon leadership. We're pursuing an aggressive and innovative product roadmap building on Intel's IDM 2.0 strategy. Today, when most of you think about an AI PC, you think about a thin and light notebook. But we have ambitions and plan to scale AI PCs so far beyond that. We're going to be accelerating the momentum of AI PCs up and down and across the stack, multiple price points, with the goal of bringing AI PCs to the masses, including Enthusiast Desktop later this year with our product codenamed Arrow Lake. And you've probably heard my boss, Pat, talk a little bit about 18A, and we're on track to fully utilize this process. As we make the transition, we'll leverage both Intel and external processes to deliver incredible PC experiences across key segments and form factors at unmatched speed and scale. I am so proud to say that we continue to execute at extraordinary scale. We're going to be going to market on B0 silicon with Lunar Lake, and we're on track to be in production in Q3 of this year. Now, I just showed you a lot of numbers, I talked about momentum, and as I said, we will win in performance, we will win in graphics, and we will win in AI. I truly believe Lunar Lake will reframe how all of you think about x86 and ultimately transform the way people experience their AI PC. And over the next 2 days, you'll hear a lot more about what makes Lunar Lake so special and why it will reign as a leadership product. Next, I'd love to invite our amazing CTO, Rob Bruckner, to take all of you behind the scenes of our client roadmap strategy, including how do we define and design our silicon roadmaps, what types of architecture innovations for our products are coming in products like Lunar Lake. Please join me in welcoming Rob to the stage.
Thank you.
Crush it.
Wow, it's great to be here. It's my first time at ITT, so what an honor, what a privilege to be here with you today. Michelle mentioned I'm going to walk you through how we put together a roadmap strategy. Now, this is really tricky in the era of AI. I don't know about you, but every 10 minutes I think I'm right about AI, I'm wrong. So trying to think about how we're going to bring a strategy for the roadmap forward is, in some bit, an art, a bit of prediction, and a bit of making it happen. So I'd like to talk about a little bit about AI. You can't do a keynote without doing something about AI, so let me give you some of the reflections I have about AI. AI is coming at us in waves. Let me talk about 3 waves that I see right now. First wave has been about really machine learning class AI. It's really bringing a more immersive experience. Things like Meteor Lake, which brought in our first NPU product into the SoC, and all of the ecosystem we brought forward, made the PC a little bit more awake, a little more toward us in the context. We spent most of our lives, those of us working on PCs, learning how to use it, interact with it. Now the PC is starting to understand how we like to interact, make us feel more comfortable, really bring an engaging experience that immerses you into the PC. We're already on the next wave. The next wave comes in with more of a generative experience. You have inference arriving. You have co-pilots. You have assistants arriving. These are making your work, your creative experiences, your collaboration, your entertainment, just one level even better. Every wave pushes each of these experiences higher. We're already thinking about the third wave. The third wave is, I believe, when the agents arrive. Agents that you are empowering as experts on your behalf. They will change how we use a PC. It's not all about what you're doing on the PC per se. This device has constraints. Beautiful device with a bigger display. As you can probably expect, I always have my phone with me. Phone, small display, smaller battery, less capability. This brings another level of compute with it. Bigger battery, more space for us to put more compute, acceleration, technology. So we have to also consider how this is going to work in a hybrid environment between this device, your portable devices, the cloud. So a lot of these experiences that are coming in waves are arriving, starting in the cloud, and then they're starting to shrink. We see model sizes go down drastically, and they start to land on the PC, where you have the most private, secure, low latency in a PC experience. And now these are going to be moving forward in a number of big bets that we have in our roadmap that I'd like to walk you through. Chris, why don't you go ahead and take this? Thank you. So what are some of the key drivers of experience? Those experiences I mentioned, the productivity, collaboration, creativity, entertainment, all rising on each of those AI waves. But they need to be performant. We need to bring the compute capability to bear to bring those experiences to life. But the compute capability can't come at the expense of portability, battery life, fan speeds, quiet performance. So at Intel, we are dedicated to bring as much compute capability into the PC while also maintaining that wonderful long battery life and quiet performance. But we're Intel as well. We don't do this once. We do this at scale. At Intel, one of our main purposes and our mission is to bring compute and technology that transforms the lives of everybody on the planet. Not just a few types of products, broad range of products. And these broad range of products are brought forward with the help of an ecosystem. This is the SoC. This is a development kit. This is not the AI PC. These are ingredients to bring the AI PC forward. It doesn't happen without our partners, our developers, all of the ecosystem coming forward. The AI PC takes this village of people, all of this deep investment across a broad ecosystem to bring a platform forward to bring AI to life. And Intel is proud of our role in the ecosystem. It's hard work to bring it at scale and open, secure. Nobody does it better, though. So let's start to talk about some of our client roadmap principles. We have, and we've been on a journey, really starting with Meteor Lake, to bring the next level of compute performance, supercharged by hybrid cores. These hybrid cores allow you to land efficient workloads in a super efficient set of Atom cores. We'll talk about SkyMont throughout the ITT, and performant cores, where you can get that fast responsiveness. These are well balanced with our operating system scheduler and our hybrid thread directors. These will continue to evolve as we go forward in the roadmap. Next, we're doubling down on Intel Arc graphics. Graphics is foundational for our experiences. It's not just about the display and gaming, it's also critical for creative experiences and bringing AI forward. You're going to continue to see us get better and better capabilities in the graphics and power efficiency in the graphics each year. This is all optimized with a multi-AI engine. With Intel, we believe that it's important to have multiple ways to do AI. We've had CPU AI for a while. Now we bring the NPU, increase the size of the NPU. We bring an AI matrix engine in our GPU, so we have 3 agents running together, bringing a full set of different opportunities with these engines. An NPU works really great for background task, running constantly. Super efficient AI engine. GPU has a bit more provisioning of the tops. This is good for when you have the GPU on, it's already running. You've got typically creator workflows. It's got a nice punch of tops at the back end of the pipeline. So each of these are needed to have a really well-balanced AI PC experience. We pull this all together with advanced packaging. Last year at Meteor Lake, we introduced Foveros technology, where we have a base die on the package, and we have chiplets that are brought forward. We extend that as well into Lunar Lake. And we're adding, with the Lunar Lake product, memory on package to best optimize the size of the full package for our AI PC products, and also optimize every bit of power efficiency for the memory interface. This all can only happen with a vibrant ecosystem. The waves of AI experiences showing up requires us to bring products like Lunar Lake forward, but also bring that with the ecosystem in mind. So let's talk about Lunar Lake. Really nice, small, beautiful product. Super excited and proud of this product. What are some of the things that I'm so proud of? Breakthrough x86 efficiency. This will change the way you think about x86. It's never been about the ISA. It's never been about the instruction set, x86 versus ARM. Power efficiency comes from the architecture that you bring within the SoC, within the IPs, within the software ecosystem, the fabrics, system caches, and many other. You will find, with the way we've architected Lunar Lake, breakthrough battery life you've never seen on x86 product. Our core performance has been optimized with really great instructions per cycle focus. IPC is a new, bigger push by Intel as we're bringing the power efficiency forward. Previous architectures, we really extended the clock. The frequency of the clock brought that performance. As you want to bring the power efficiency, you bring some of the frequency down while increasing the IPC. With higher IPC and that frequency of the clock, you get the same and higher performance. We're on a journey to show massive double digits improvements in IPC. You'll see some of this today in the ITT sessions. With massive leap in graphics, we brought XE1, Meteor Lake, XE2, big boost in graphics back to back. Already working on the next one for the Panther Lake generation. You're going to see every product we're launching a big leap in graphics performance. And we unmatched AI compute, total of 120 PTOPs against 3 different AI agents. This is a revolutionary product. It will change the way you think about Intel and AI PC. But I'd like to bring now our SoC architect and our design lead, Yaron and Eric, to the stage to walk you through the next level of detail. Yaron, Eric.
Hello, everyone. After several years of intensive work, we are super excited to stand here and introduce Lunar Lake architectural goals and what we have achieved. Let's start with a nice build. Lunar Lake is not a traditional Intel CPU design. It's a full integration of the most critical elements required for computing. It integrates compute, I/O, memory, and security, all unified within a single chip, introducing a leading product optimized for low power and high performance. As we look at the slide, you will notice the composition of Lunar Lake. The compute tile is at the heart of the system, hosting most of the significant computing IPs that power the system intelligence. The second tile is the platform controller, or the BCD tile, where security and connectivity are located. These 2 tiles are assembled together into one package using Intel Advanced Foveros technology on a passive-based die, creating a compact and powerful chip. But it doesn't end here. Memory is crucial, and therefore, Lunar Lake enabling fast access to data, reducing latency, and reducing the overall power of the system. Memory on package directly contributes to the performance, power, and footprint. By shortening the traces to memory, memory on package achieves up to a 40% reduction in firepower. Additionally, it allows a smaller footprint. It frees up PCB layer and reduces the complexity of the board. This leads to a significant board area saving, up to 250 millimeters square, contributing to the compact design of premium devices. The memory on package supports up to 32 GB with 2 ranks of LPDDR5 memory, reaching up to 8.5 giga transfer per second, and featuring 4 60-bit channels. In the next slide, Arik and I will describe each of the components in more detail. Now, let's discuss Lunar Lake goals. We developed Lunar Lake with 4 goals in mind, which guided us along the definition and execution process. First goal was to deliver the most power-efficient, cool, quiet, and performing mobile CPU. Second, to deliver strong graphics with a great user experience. The third goal was to bring leadership AI capabilities, ensuring it is not only delivering outstanding performance or user experience, but also ready to address future AI usages. Fourth, but very important, a major improvement in energy efficiency. We took all the goals with the target to enable Lunar Lake architectural goodness to scale up to the next generation. We will describe the extended scalability later these slides. I would like to invite Arik, but before that, I want to go over the goals and update you that today we are standing here, and I'm happy to stand here to share with you that Lunar Lake has achieved all its goals. It brings significant leap in multi-thread performance, single-thread performance, AI throughput, graphics, performance per watt, and battery life. Now, let's switch to Arik that will lead us through the architecture. We will show you the improvements in each of the vectors as we go.
Thank you, Aaron. To address Lunar Lake architectural goals, Lunar Lake brings a whole new microarchitecture with a redesigned compute tile. Let's take a look on the compute tile components and see. Lunar Lake is designed with 8-core hybrid configuration. It has 4 high-performance cores optimized for outstanding single-thread performance and intensive workloads. It also has 4 efficient cores, which are optimized for energy. The efficient cores are the backbone of Lunar Lake ability to deliver sustained performance for casual use without compromising on battery life. Let's look at the performance cores, or the P-core cluster. It uses a new Lion Cove cores that are designed for high single-thread performance. Lion Cove is a single-threaded core. It has a 2.5 megabyte of L2 cache, and it is optimized to balance performance per watt per area. These 4 cores also share a 12 megabyte of L3 cache, creating a powerful unit that can scale to the highest performance levels. Alongside the P-core cluster, Lunar Lake implemented a new E-core cluster, which brings a major upgrade to the previous low-power island. It is using a new SkyMode core with improved caching, enhanced fabric connectivity, and power delivery. The E-core clusters is delivering twice the performance of the previous generation. In addition, SkyMode core doubles the vector and AI throughput for handling AI tasks and complex calculations. Overall, the E-cores are designed to deliver robust performance for both demanding and routine tasks with excellent efficiency. The P-core and E-cores operate flawlessly together. They are complementing each other across a wide range of tasks. In Lunar Lake, while the E-cores are the primary workhorse for most of the tasks, the P-cores are activated for high-performance demands. The cores are structured in clusters such that each cluster can power on or off independently, taking efficiency even further. The presented graph here is an illustration of Lunar Lake's core efficiencies, with power on the x-axis and performance on the y-axis. You can see that at the low power range, the E-cores are outperforming the P-cores, highlighting their superior efficiency. The graph also highlights the P-core's impressive capability for achieving much higher peak performance versus the E-cores. Together, they scale across the entire range efficiently. Now moving to graphics. Lunar Lake GPU engine is based on the Xe2 new microarchitecture. It comes with 8 Xe cores that provide great graphics experience and performance efficiency. It also implements 8 enhanced ray tracing units, which greatly improve lighting and visuals. The graphics engine did not only improve gaming and creation, it also significantly enhanced AI throughput by adding Xe matrix extensions. It delivers outstanding number of up to 67 PTOPs on graphics, which shows our commitment to deliver the best AI performance. Lunar Lake also introduces Xe2 new microarchitecture for display and media, designed to deliver the best-in-class visual experience. Our media supports video-coded H.266 or VVC, which is a major upgrade in our decoding capabilities. The display supports 3 pipes with the latest DP 2.1 and HDMI 2.1, and additionally, a dedicated low-power EDP 1.5 channel ensures energy efficiency and high-quality display performance. Lunar Lake also upgraded the IPU, the imaging processing unit, with enhanced temporal noise reduction, multi-frame still processing, and improved dual exposure staggered HDR. Overall, Lunar Lake Xe2 graphics, which come with a mature and optimized software stack, brings over 50% more graphics performance and more than 3.5x AI throughput over the previous generation. It's a huge leap in graphics. In addition to our graphics engine, Lunar Lake continues to strongly invest in AI acceleration. The upgraded neural processing unit delivers up to 4x more PTOPs versus previous generation, reaching up to 48 PTOPs. It features 6 neural compute engines with 9 MB cache to accelerate AI computation in impressive low power. This NPU also includes 12 enhanced shaped DSPs to further enhance various AI usages. This NPU, with improved architectural efficiency, is a big step for Intel to bring AI at scale. Looking at all the engines together, the combined CPU, GPU, and NPU delivers up to 120 platform PTOPs, which will make Lunar Lake best design the most powerful AI PCs. This AI compute horsepower ensures Lunar Lake can efficiently tackle a broad spectrum of AI challenges. We are truly happy that we were able to achieve that. Now let's summarize the compute tile highlights. We have the P cores for running intensive workloads, the E cores to provide balance of performance versus power, the NPU that brings significant improvement for AI PC, being very power efficient. The XT2 engine, demonstrating great mobile graphics experience and AI acceleration. The media and display to ensure an excellent output quality. And the IPU, which brings great camera experience with reduced power. Together, these components combine Lunar Lake XPU IPs. Now that we have seen the compute tile impressive set of engines, I'd like to invite Yaron to give the details on the architectural framework that integrates the engine together into a one efficient system.
Hello again. We have structured all the XPUs under one monolithic die on a leading process. The compute tile also contains memory elements, such as memory controller, DDR5, memory crypto, and integrity engine. The XPUs and the memory components are connected to a new network on a chip and a new caching scheme. The two are reducing the power and the latency of the system. Lunar Lake also introduces a memory side cache designed to elevate overall system efficiency performance. With this 8 MB physical cache, we were able to reduce traffic to DRAM, which lowers power consumption and is improving the performance. The cache is engineered to both enhance latency and bandwidth, ensuring the data is delivered rapidly when it's needed. It also provides caching for the IOS engines to streamline data flow, improve response time. The cache ways allocation is highly configurable, allowing dynamic allocation between engines for various use cases. Lunar Lake advances the idea of low-power island, pushing the boundaries to create top-of-the-line 4-efficient core cluster. It is not only doubling the core count, but also doubles the L2 cache size and support higher frequencies, expanding its application range. The enhanced memory side cache substantially improves the efficient core instruction per cycle, while also reducing the DRAM power. Furthermore, Lunar Lake introduced dedicated power control and voltage rails for core and for the L2 cache. This allows for independent management of power level, distinct from other computing and memory elements, optimizing energy efficiency across the system. Lunar Lake also redesigned the power delivery and the power management scheme. We went all the way, implementing a rich set of voltage rails for different components, allowing P-core, E-core, graphic, and memory component to operate independently across the voltage range. Voltage is a critical piece of the efficiency puzzle, as it improves Lunar Lake IP and SoC power consumption. In order to achieve the luxury in rails, Lunar Lake is using 4 power delivery integrated controller chips that not only allows the fine-grained topology, but also enable enhanced telemetry such that power is controlled in a better resolution. Lunar Lake introduces major change in the power management architecture, designed to optimize performance efficiency. Starting with the Intel Trade Director, which now places a stronger focus on efficiency, allocating tasks and drive containment of tasks into efficient cluster. The power balancer has been optimized, ensuring that the system resources are utilized effectively such that every watt consumed wisely. We have also enhanced the sleep states, cope with the modern usages, in which multiple applications are running concurrently and wake the system frequently. Furthermore, machine learning-based workload classification and frequency control dynamically adjust processor speed, delivering optimal performance precisely when it's needed. Together, these advances in our power management strategy not only maximizes performance, but also minimize energy usage and contributes to Lunar Lake power efficiency. Overall, the PMIC, the enhanced thread director, the memory side cache, and the improved eco cluster brings up to 40% SoC power saving in real-life usages. These innovations work together to dramatically extend battery life, ensuring Lunar Lake-based system lasts longer on a single charge. This is one of the biggest improvements Intel ever did between generations. Now, let's move to Arik to go over the platform controller tile.
Tile, or the PCD, is where security and connectivity are integrated. I will now describe its main capabilities. Lunar Lake PCD security components delivering a robust, integrated security solution. The three built-in security engines are designed to establish a solid foundation for system protection. The first is the new Intel Partner Security Engine, which provides a hardware-based root of trust for third-party security services. The second is the Intel Silicon Security Engine that ensures the integrity of the processor, offering protection against a range of threats. And lastly, the Converged Security Management Engine, or CSME, that secures data across the platform starting from Power 1. Together, these three engines secure the entire Lunar Lake system, offering a trusted environment for users. As for connectivity, Lunar Lake upgrades the connectivity suite. The new Wi-Fi 7 is now fully integrated, offering the fastest and most responsive wireless experience available. It also integrates Bluetooth 5.4 to ensure seamless pairing with the latest devices. Together, they position Lunar Lake at the front of the wireless communication technologies. Lunar Lake also introduces great wired connectivity. It integrates 1 gigabit Ethernet port for robust connectivity, 4 PCIe Gen 4 and 4 PCIe Gen 5 for high-speed connections, and also 3 integrated Thunderbolt 4 ports that provide a one-stop solution for data, display, and power with a mix of USB 3 and USB 2 that ensures comprehensive compatibility. Overall, the PCD set of interfaces ensure that Lunar Lake is ready for any connectivity demand. After covering the computile XPU engines, the framework that connects them, and the PCD, it's important to say that Lunar Lake architecture builds a foundation for the future client generations. As such, it added the required infrastructure to cope with different options of dial partition, as well as future scaling to multi-compute tiles. This strategic approach was to enable each segment to select the right mix of die partition, taking the trade-offs between cost and performance. Lunar Lake SoC architecture is both IP agnostic and partitioning agnostic. In addition, we are focused on improving the coherency across all components, and the implementation is an hierarchical coherency structure. To make Lunar Lake IP agnostic, we introduced the Scalable Fabric Gen 2. These fabrics separate the physical layer from the protocol layer. The separation allows us to transfer multiple functional protocols on the same unified physical protocol. As seen on the screen, the fabric scale across the two tiles allows placing the right transistors on the right tile, considering the tile content and considering the tile process node. The die-to-die IP that links between the tiles carries the same fabric physical protocol and acting as an integral part of the Lunar Lake SoC, such that the two tiles are connected as one unified system. This enables Lunar Lake to be partitioning agnostic. And last, Lunar Lake implemented hierarchical coherency structure with home agent and multiple coherency agents. It enabled the integration of the memory side cache such that it can be used by any agent on the system. This hierarchical structure also allows the architecture to support multiple compute tiles very easily, as you will see in the next coming generations. As we approach the end of our part of the presentation, let's look at Lunar Lake's significant achievement versus our previous generation. Lunar Lake tackled every vector. Despite the reduction in thread count, Lunar Lake still gives a significant speed up in multi-thread performance. In terms of single-thread peak performance, we have seen double-digit improvements, pushing the boundaries for individual core processing. But the story of Lunar Lake is not peak performance. Lunar Lake also delivers the same Meteor Lake single-thread performance at half of the power. So when it comes to productivity, we have more than twice the performance per watt, showcasing significant gains in energy efficiency for everyday use. The AI throughput brings a dramatic leap with over 3 times the throughput across the NPU, GPU, and CPU, marking a new era for AI-driven tasks. As for graphics, Lunar Lake delivers up to 50% uplift in performance, translating to a much better experience for gamers and creators. And finally, for battery life, Lunar Lake reduces the SoC power by up to 40%. This is a major step for mobile, and you will notice it. To conclude, we have seen how Lunar Lake brings a leap forward in efficiency.
These advancements together represent the potential of Lunar Lake, setting a new standard for performance and efficiency to our next generation client product.
With that, we'll hand it back to Rob.
Okay. Pretty substantial amount of change in a platform. Hope you're seeing some of the major efforts we put into this type of product. This is why I came back to Intel, this class of product. This is the first major project I was a part of at Intel, and we're super proud of it. Over the next 2 days, we have many sessions for you to really dig deep into the architecture, ask your questions, challenge us, learn from us. I understand this audience is a mix of partners and media analysts. Any media analysts here? Raise your hand. Yeah? You mind standing up for me? Please. I want to thank you for being here. You're going to help us write the AI PC story, and you're going to hold us accountable when we need to continue to improve. I hope you learn from us over the next 2 days, just as we're listening and learning from you. Developers, ecosystem partners. We have any of those today? Please stand up. Come on. I want to thank you. Thank you for your patience as we deliver better power efficiency and unlock your creativity. We aspire to be your best partner on the AIPC journey. We hope this ITT event inspires you and enables you. This is Lunar Lake. Now, together with all of you, let's go do something wonderful. Thank you.